Hello, we are Team Phoenix and here we are presenting analysis and prediction of liver diseases in Indian patients. This data set contains liver patient records and non-liver patient records collected from northeast of Andhra Pradesh, India. Our aim is to analyze the data and perform TLE on the dataset to obtain a clean dataset for training and prediction. We have used statistical analysis and hypothetical testing methods to determine the type of data we have obtained. Prediction of whether a person has liver disease or not has been done based on many factors such as gender, age and compositions of different chemical compounds present in our body like bilirubin, albumin, proteins, alkaline, phosphatase which determine the state of a person. We determine the relation between each of the factors and analyze their contribution to the final prediction about a person being diagnosed with disease. First we import required packages. Then we import our data file which is in CSV format. As we can see from the data we have varying data. We start by checking if any column values are null or nan so we can clean them if we have them. Then we move on to visualization. This first graph shows the number of patients diagnosed with liver disease and number of patients not diagnosed with liver disease. This graph shows gender distribution. These graphs show gender distribution with liver disease using a bar graph. The further graphs show distributions like total bilirubin and direct bilirubin, aspartate aminotransferase and alanine aminotransferase, alkaline phosphatase and alanine aminotransferase, total proteins and albumin, albumin and globulin ratio and albumin, albumin and globulin ratio and total proteins. We add extra columns for gender. Here we again check if any value is null and check for mean. This graph shows correlation between all the features. Next we move on to hypothesis testing. Initially we assume the null hypothesis is true, that is, there is no relationship between the features and possibility of presence of liver disease and if any present, it's purely by chance. We try to disprove the null hypothesis. We do that by proving that the dataset follows a particular distribution. Here we use the Shapiro test to check whether the data is in normal distribution or not. We get a p-value which is above 0.05 which denotes that the distribution is normal. We also use normal testing to confirm the distribution of the dataset to be a normal distribution. Finally, in the machine learning part we import some modules again to split data and apply classifiers. We divide the dataset into test and training data with a 7:3 ratio. We perform logistic regression and see the results as training and testing score, coefficient and intercept, accuracy, confusion matrix, and print classification report. Again we perform Gaussian naive Bayes classifiers and do the same. We can now rank our evaluation of all the models to choose the best one for our problem. Conclusion: this project focuses on predicting liver diseases with the help of machine learning techniques. Gaussian naive Bayes classifier was used to predict whether a given patient is likely to have a liver disease or not. An early diagnosis can help the patient from a serious scenario.